Here's a system that's not so nice. Now, my previous examples, I designed them all to come out nice integer solutions. This one I just kind of made up. So what's going to come out of it is not very pleasant. So let's start with maybe substitution, and then I'll show you that that's just a very bad idea in this case. So if I was going to do substitution, I'd pick one of these two equations to solve for. The easier of the two seems to be the bottom one. So I would take this one and solve it for, oh, well, x. If you solve for x, I'll skip all the nasty, dirty work, you're going to get negative 3 halves y minus 7 halves. And then you have to take that and plug it in here. So then you'd have to multiply this all by 3, and you'd get negative 9 halves y minus 21 halves. Minus 5y is equal to 3, and solve for y that way. All these fractions are going to get in the way. So the better way for this one for sure is addition, or the way I like it is elimination. Alright, so if we're going to do addition elimination on this thing, I like calling this one 1, call this one 2, equation 1, equation 2. And let's say we get rid of the x's. That seems reasonable. So I would multiply the top one by 2 and the bottom one by 3. That would make both of them 6. Just make the second one negative. So if I do 2 times the first one minus 3 times the second one, at least the x's will eliminate. Alright, so 2 times the first one would be 6x minus 10y. And don't forget the other side, 3 times 2 is 6. Alright, negative 3 times the second one would give us negative 6x minus 9y. And let's see, negative 3 and negative 7, that would be a positive 21. And let's add these two together. So here the x's are going to go away. Here you're going to get negative 19y is equal to 27. Alright, so y is going to equal, after dividing by negative 19, negative 27/19. Oh, pretty answer. Now you have a choice. You can take that, plug it back into one of these equations and solve for x, but again you're going to have to be dealing with that fraction. So another way of doing it is just do elimination again, and in this case get rid of the y's. Now to get rid of the y's, I need to multiply him by 3 and this one by 5, and they're already opposite signs, so we don't have to worry about changing signs. So equation 1 I'm going to multiply by 3, and I'm going to add on to that 5 times equation 2. Alright, so 3 times the first one would be 9x minus 15y, and 3 times 3, of course, is 9. And then 5 times equation number 2 up here would be 10x plus 15y, 5 times 3y. And then on the other side would be 5 times negative 7, or negative 35. We take these two and add them together, and here the y's will go away. We're left with 19x is equal to negative 26, I think. And if we divide by 19, we get x equals negative 26/19. Alright, so the solution to this is going to be the coordinate where these two lines cross is at negative 26/19, comma, negative 27/19. It's not that bad with elimination, even with the fractions, because you really don't get to the fractions until the very, very end.